Going back and reviewing a little bit, in 12.1, we were going through and taking a look at how to estimate a limit using a table. But the tables take a lot of work, and the answer isn't even very good. It's just an estimate. It's not even exact. Section 12.2, day number 1, we were using properties of limits instead to go through and evaluate a limit. Again, the process is pretty long. Those properties of limits, you have to keep breaking things down and breaking things down, but eventually you can come up with an answer, and it's an algebraic exact solution. It's not an estimate. So generally that process is a little bit better. You may have noticed this when you were going through and doing the 12.2 day 1 assignment, but there is something that we could do that would be a little bit easier. For 12.2 day number 2, the directions are to use direct substitution if possible to evaluate each limit. And if it's not possible, then we just explain why it's not possible. And basically, our book goes through and explains that if you use direct substitution, if you take a number and you substitute into your variable, you can evaluate the limit without using those properties that took so long to do on the day 1 assignment. And what that has to do with is what the type of equation is that we have, and then whether or not we can use that direct substitution technique. So let me run through and kind of show you what I mean by that. We're going to use direct substitution if possible to evaluate each limit. The if possible part, that's what we need to take a look at for right now. And for the first type of problem we're going to look at, we're going to be looking at a polynomial. And what you basically need to know is this. Polynomials are continuous. Polynomials are continuous, so the limit always exists everywhere. What that means for us is that direct substitution will work every single time for a polynomial. So let's look at an example of one of those. If we have the limit as x approaches 2 of negative 2 x to the 4th plus 3 x cubed plus x squared minus 2x plus 5. So here is our expression. This is a polynomial, if you remember what polynomials are. Basically, they're kind of like quadratics, but you could have higher powers to them. There are some things that would not be polynomials. If we had a variable in the bottom part of a fraction here, that would not be a polynomial. That would be a rational function. If there's like a square root in here, that also would not be a polynomial. But for polynomials, things that look like this, because they are continuous, we can use direct substitution to evaluate. We do not need to use those properties of limits like we did in the day 1 assignment. So all I need to do is this. With these directions, use direct substitution if possible. I need to look at what I have and see if it is possible. This is a polynomial, and it's always possible to do direct substitution with a polynomial. And all I'm going to do is take our limit value down here. We have the limit as x approaches 2. I'm going to take that number and I'm going to substitute it directly in for all of the x's in our problem. So this is going to look like this in the next step. When we do direct substitution, when you take the 2 from here and you start to plug it in, that's when the limit goes away. We don't need the limit in front anymore. So I'm just going to take that 2, I'm going to plug it in to all of those x's. So that looks like this. We would have negative 2, and we had an x to the 4th, so now we're going to have 2 to the 4th power. And then plus 3x cubed, so that's going to be plus 3 times 2 to the 3rd power, plus x squared is going to become a 2 squared, and then we have minus 2 times x, or minus 2 times 2, and then our plus 5. And now we just need to evaluate that and come up with our solution, and that will give us our answer. 2 to the 4th power is 16 times a negative 2 is a negative 32. 2 cubed is 8, and 8 times 3 is 24. 2 squared is 4. 2 times 2 is 4 again, but we do have that subtraction in front, so that would be a minus 4 and then the plus 5. So negative 2 plus 24 gives us a negative 8. These 4's basically would cancel out, and then plus 5 gives us a negative 3. So we have a negative 8 plus 5, so the final answer is a negative 3. That is how we can use direct substitution, and one of the times when we can. So again, sometimes direct substitution is possible, sometimes is not. What we need to do is take a look at our original expression, and if we have a polynomial, we know we can do direct substitution right away. You can always do direct substitution whenever you have a polynomial.